Here's an example of an exponential growth problem, and we're told that the population of a city grows exponentially at 5% annually. And so the first thing that we're asked to do is to write an equation for P of t, the population, over time. And our exponential growth formula generically is that P of t, some population which changes over time, is P0, the original population, times e raised to the power kt. And we are given some information which allows us to write a more specific equation, and that is to say that our population at any given time is going to be the original value, which is given to be 10,000, times e raised to the power, and in this case k is 5%, so we're going to write that as 0.05 times t. And we can substitute various values for t in order to find the population at various times, in this case in years. So the second part of the problem asks us to find the population first after 10 years and then after 30. So now we can use this specific equation to plug in values for t. The population at 10 years is going to be 10,000 times e to the 0.05 times 10. And simplifying the exponent, we get 10,000 e to the 0.5. And if you just use a calculator to work that out, you end up with about 16,487. Now we can also find the population after 30 years, so we'll do the same process, plugging in 30 years for t. So we get P of 30 is equal to 10,000 times e to the 0.05, this time times 30, and that's equal to 10,000 e to the 1.5, and again, using a calculator, we eventually get that this will give us 44,817, rounded off. And so you can see that this small town of 10,000, as it grows, after 10 years, it's at 16,000, about 1.5 times. But after 30 years, it will more than quadruple. In the problem, it doesn't ask us to make a graph of this function, but we can to get an idea of what the population looks like. So if we set up some axes, we've got time on our horizontal axis going from 0 to 30 years, and we've got population on our vertical axis going from 0 to 50,000. And so if we plot these points, when time is equal to 0, we can see that the exponent will be 0, e to the 0 is just equal to 1, and so the population starts off at 10,000. When we are at 10 years, the population is about 16,500, and so we're here. And at 30 years, the population is at about almost 45,000. So we'll put a point here. And we can see that the trajectory of this graph is increasing, and the rate of increase is going up.